Hey guys, in this lecture I'm going to talk about Java constructs. Java constructs are some building blocks of the Java. Um, so far we have learned some of them. We started with the Java objects, which is the main building block of the Java, and also we learned class as the abstraction of similar objects, and also we learn interface in the previous lectures. All right. So in these two lectures, I am gonna talk about the abstract class, which is another Java construct, nested class. A nested class has some flavors. Uh, Inner class or regular inner class, a static nested class, anonymous class, and after finishing the nested class, I'm going to talk about lambda expressions, which is actually an introduction to lambda expression. Then we will get back to this lambda expression at the end of the semester when I am talking about the advanced Java. Okay, so in this lecture, I'm gonna cover this portion, the red portion, and in the next lecture, I will finish these two as well. Okay, now let's start with abstract class. What is abstract class? So I'm gonna explain the concept of the abstract class via an example. So we get back to our very familiar classes, dog and cat, and also animal interface. So we introduce these classes and the interface in the previous lecture. So cat class, as you see, implements the animal interface, and it has one instance variables and one uh, implemented method, get voice. And the same thing in the dog class. Okay, so let's focus on this similar method, get voice, that it is similar in both of them, right? Okay, so let me ask this question. Um, Before asking actually the question, let's look at uh, the class diagram of the cat and dog, and also the animal interface. Okay, as you see, we have an public get voice here on both of them, a private instance variable voice here, and here in the interface we have an abstract method, get voice. So you see, we put the abstract method inside the curly braces. Usually in class diagrams, we show abstract elements, abstract members with the italic font, but since Violet does not support the italic font, I put them inside curly braces. Uh, okay, so now the question is, this implementation of the get voice in both dog and cat class are exactly the same as you saw in the previous slide. Why won't we create a default method in the animal instead of having an abstract method? Let's implement that by default keyword, as you know from the interface lecture. So why didn't we do that in the previous lectures? Okay. Uh, Yeah, because we couldn't. Why? Because the get voice in the previous slide has dependency to voice. It is returning, it is returning the voice. So it is calling this voice, it's returning an instance variable. So if you put this here, it it wants to return something that does not exist here. Okay? So because of this, we cannot do that. We cannot factor out the get voice implementation and put it in the animal interface. Okay, so to be able to do that, I'm gonna add something in the cat and dog uh, classes. So we add a new method that they are similar, and I want to show you that how we can factor out them and put in the interface. Okay, so here is our new code. So our new code, we added a show voice. In the show voice, we are calling the get voice, which is this guy, to return voice, and we put it in this variable, and then we just print that. Okay. Uh, yeah, the same thing on the dog method. Okay. Now if you look at these two, you see there are both similar, exactly the same thing, and they don't have any dependency to the instance variable because this guy is calling the get voice. It's calling this guy. It's not, it's not using this directly. It is calling the get voice. But with this technique, we remove the dependency, between a method and the instance variables. All right. Okay. So now let's see. So now we have two exactly similar methods in both of them. All right. We factor out them and put it in the interface, but note that we need this default keyword. Okay. So here is our old animal interface, and here is the new one. Look at this. So this is exactly the same method. The only difference is that uh, we just put the default keyword here. Otherwise, your code won't be compiled. Okay, cool. So far, so good. Uh, okay, so what's happening here? Uh, this get voice, what get voice is this? This get voice. But this get voice is not implemented. It is an abstract method. No matter at all. It doesn't matter, right? So it means that inside a method in the interface, you can call an abstract method. That's fine. Okay, cool. Let's get back to the UML diagram one more time and see what would happen. What happened actually. So we had a public show voice here, and they didn't have any dependency to the instance variables, right? And we factor out them and we put it in the interface like this. Look at this default. It shows that it is an implemented method, and these brackets, the curly brackets, shows that this guy is an abstract and unimplemented method. All right. Okay. So we could solve a problem What problem was that? We violated, uh, the dry rule. What is dry rule? Don't repeat yourself. So we had some repeated code, and with this technique, we could factor out that method. And now we have only one instance of that method. All right. Okay. So, but the problem, the question could be this. This is the Java 8, way of solution. In Java 8, we have interfaces that can have implemented method. Before that, we couldn't do that, right? The ingredients of the interfaces was only abstract methods and also constants, all right? So Java 8 added this feature that we can have implemented method. Now the question is, okay, so if this is the case, how the developer solved this problem with Java 7 or older, right? Yeah, that's how we introduce abstract class. Actually, we used to use the abstract class before Java 8. So let's see what is abstract class. Abstract class is something between the interfaces and concrete classes. Concrete class, it means that it's a regular class, right? So something between that. What does it mean? So interface in Java 7 and older, let's assume that it can have only abstract methods, right? And concrete class or regular class can have all implemented methods. So something between these two, it means that abstract class can have some unimplemented methods and also some uh, concrete methods or implemented methods. So something between them. Okay, cool. All right. So here is the ingredients of the abstract class. All members that can concrete or regular classes can have. So it means instance variable, methods, whatever that a concrete class can have. And also abstract methods. So this is the ingredient of the abstract classes. Okay, so let me get back to the previous example and see how we can use abstract class to solve the dry violation that we mentioned in the previous slide. So this was the Java 8 solution. We are still have the interface animal, and this is an abstract method, and this is a concrete method or implemented method or default method, right? The same solution with the abstract class like this. So we have the same method here, which is implemented method. We have the same abstract method here, but here we have, instead of the interface, we have abstract class. Okay, so abstract class can contain abstract methods and also concrete methods or implemented methods. Okay, so let's see. Here I use a convention for naming the abstract class. For example, apps. We add apps at the end or even at the beginning of a name to be able to distinguish that this is an abstract class. And also we have to mention this abstract class, abstract keyword here. All right. Okay, so if we've solved the problem with the abstract class, then let's see how the cat and dog classes look like. Okay, so in the previous solution, we implemented cat and dog implemented the animal interface. But now cat and dog should extend the animal apps, right? So this is some kind of inheritance now because this is kind of class, right? It's a half class, let's say. So we are extending the animal abstract class, all right? And the same thing for the dog, of course. And also the point here is when you extend an abstract class, again, Java will force you to implement all abstract methods, right? So, for example, this getVoice was an abstract method inside this animal abstract class, right? If we don't implement this portion, then your code won't be compiled. Okay, all right. So now let's look at the UML diagram. What happened? So here, this is our old solution with the interface, and here is our solution with abstract class. All right, all right. Okay, now let me give you some notes here. So as you saw, the child class extend abstract class. In in other words, child child class, let's say cat and dog, and the abstract class, let's say animal apps, they there is an is a relationship. So whatever we said in the inheritance is applicable here as long as we use this extend keyword. Okay, so all visible, implemented method will be inherited to the child class. And so note that the visible, so the visibility and whatever we said about the visibility of the inheritance is applicable here. And also, uh, in the child class, we need to implement all abstract methods that are coming from the abstract class. And the other note is when you have an abstract class, you cannot instantiate it. So, like the interfaces, abstract classes cannot be instantiated. Basically, as a general rule, you can instantiate something that is concrete. It means that all of the, its members are concrete and implemented. So the only thing that we can instantiate based on this rule is the concrete classes or regular classes. And also the other note is you can use the abstract class in a polymorphic relationship. So you can have on the left side, you can have an abstract class. So an abstract class you can have here, and equal to here you can instantiate a regular class. So before we could have here interface and here class, right? Now we can have abstract classes as well. All right. So this is the way that we create a polymorphic relationship. In the polymorphism lecture, we use the passing a concrete class to an interface argument of a method, right? But all of the things that we said for passing something to an argument is can be repeated for the assignment as well. So in other words, if you have an interface here and this is a class that is implemented, uh, so this class implemented this interface, right? So again, there is an is a relationship between this concrete class and this interface. That's why you can use the polymorphic relationship here, right? So the same thing can be said for the abstract class. So you can put abstract class here as well. Okay, so in UML diagram, as I explained before, we need to use italic font to represent the abstract members, classes, methods, whatever, right? Or we need to put an abstract like this, a keyword inside the curly braces, and we can add this before or after the class or method name, right? But I simplified this. I just put the name inside the curly braces, all right? So that's fine for this course. You just need to know. Okay, so that was whatever I had for the abstract classes. What is nested class? So as its name is saying, it means that there is a class inside another class. So in other words, a class can have another class as its member, right? Okay, so this little object here, little class here is inside the bigger class like this. So since the nested class is a class actually, so it can have its own class members, right? But there are some restrictions that I'm gonna talk about them. Okay, so for the nested class we have several flavors, and these flavors are: one, inner class; two, static nested class; and three, anonymous class. All right. So I'm supposed to cover in this lecture these two. Okay. And we'll leave the anonymous class for another lecture. So let's start with the inner class. What is inner class? All right. So bring up your Eclipse and follow me. So we want to create an inner class. So let me bring up my Eclipse here. So I create a class. Let's call it uh, my author. It means my author class. Okay. And inside that, I'm gonna define another public class. Let's call it my inner class. You see? All right. Let's see. Let's follow the lecture note and see what we need. So an inner class can have, yeah, instance variable, methods, and other nested class. What does it mean? Because it's a class, right? So we can create a, let's say, private string name equal to Tom. So this is an instance variable for our inner class. Okay, so let me comment here that it's my inner class to be less confused, all right? And also we can have a method, for example, public void, um, let's say an inner method, okay? So whatever it is, just put some code here. All right. And also it can have another inner class. So you see, whatever that a regular class or a concrete class can have an inner class, since it is a class, it can have. All right. So let me create a public class. Let's call it my inner, and you can continue this, right? Okay, so let's see what else we have here. Okay, so there is a restriction that inner class cannot have static members. All right, so this is the first restriction we encounter here. So for example, this method, if I make it static, then it will complain. All right, so no static members. So the same thing for the uh, instance variables as well. All right, so since it cannot have a static member, it means that it cannot have an main class. All right, okay, so far so good. All right, so how about the access modifier? An inner class, and its members can have all access modifiers. Is this true? Yeah, let's check. So this is inner class. The inner class itself, let's make it private. Yeah, that's fine. Remove it as a default. That's fine. Protected. Yeah, that's fine. And the same thing for the other. Let me check one of these members. For example, uh, let me check that method. All right. So public, fine. Remove it as a default, fine. Protected, fine, and also public is fine. Cool. So all access modifier are applicable in the inner class. Okay. Now let's ask some questions. The first question we are asking is what members of author it sees. So we are looking, we are inside the inner class, and the question is what we can see from here, right? The methods, the let's say the instance variables, private, public, whatever, what we can see. All right. Okay, so let me bring up here. Let me create a private, let's say integer x equal to 10. Okay, so this is a private member of the author class. Now let's go to the inside the inner class. Do we have access to this x? For example, in this method, can I use that x? Let's see. X equal to 12. No complaint. No complaint. So it means that the inner class can have access to all members of the outer class, right? So even though it was private, but we have access. So it's not strange actually. Why it's not strange? Let me even make it private for sure that, or even make it this one private as well. You see, there is, yeah, I type it incorrectly. So even though all of these are private, but still, well, you see the some, members of the inner class have access to the, all members of the uh, author class. All right. So I was saying that it is not strange because just forget about this inner class, and let's say we have a private method. Oops. Yeah. Let's say we have a private void method. Let's call it an author method. Yes. So inside a private method, Do you have access to the instance variable? Yes, you have. So for example, you can say x equal to now 15. You see, no problem. So, so it means that all members of a class have access to other members. If we have another method inside the other class, you can call it here, right? There is no problem. So if this is the case, then the same thing happens in the private class, the inner class, I mean. So inner class have access to all other members. All right. So even you can call this method here, for example. Let me remove this guy. So an author method, you can call it, right? So in summary, inner class have access to all members of the outer class. All right. Yeah. Another question. Now the question is what author class sees? So look at this guy. The author class is looking, the inner class. So first let's focus on the inner class itself, not its member, right? So what author class can see? Can see the inner class. Okay, let's see. All right. So let me, yeah, just removing those unnecessary things. Now the question is, can we see inner class, the inner class itself here, for example? Okay, so let me instantiate it and see I can see that or not. So let's say private my inner, yeah, my inner equal to new my inner, no problem. So it means that the author class can see the inner class because it's in member, right? So we are not surprised about this. Since it is its member, it can see it, right? The same thing we can have inside the method. Let's instantiate it inside the method. So it is complaining that we already have probably no, just that private thing. All right, we can have instantiated this inside the method. So what is the answer to this question? What author class sees we are asking exactly the inner class itself, right? It can, yes. So the response is regardless of the all of the type of the modifier. So here you see I made it private, but here the inner class is private, it can see that, no problem. So definitely if we make it public, no problem again, and default, no problem, protected. So regardless of the access modifier of the inner class, the author class can see it, right? So this is the bottom line of this slide. Okay, now this next question is more important. So what members of inner class the author class can see? What does it mean? It means that now we have a private Tom, name here, right? The question is, can author class see this? Okay, so let me make it public for sure. Make it this public as well, even though I don't recommend to make, to have a public instance variables at all. No, never ever. But this is just for a demo. I want to make sure that, in the worst case, which is the this guy is public, this guy is public. I want to see that the author class can see this or not. Let's see. As an instance variable, let's say, probably it's not a good example. Let's look at inside this method, right? So inside this method, can I say, for example, name equal to, let's say, Larry? No. Complaining. What does it mean? It means that the outer class cannot see the members of the inner class. So why is that? What is the reason here? The reason is whatever we have inside an inner class, the scope of them is from this bracket until this bracket. So all of these stuff are meaningful from this bracket until this bracket. Just consider them as a local members, right? And an author class, not author class, any other classes does not have access to local variables, local stuff that we have inside the methods or we have inside an inner class, right? The same thing happens for the method. For example, here, if you have something, let's say, for example, int y equal to 15. So this y is a local variable for this particular method. It cannot be seen outside this method. So the scope of the y is from here to here. All right. So we are not shocked about this, that outer class cannot see the members of the inner class. All right. Okay. Let's see. Yeah. So I explained all of this, and these are just for your reference. Now the question is how we should instantiate an inner class inside an outer class we are talking about. So actually we already did this. So you see here I instantiated here and also I instantiated here. So inside a non-static method we are fine here. So you can instantiate it like other classes that you instantiate. But if the method is static, yeah, then we have problem. We have problem here, right? Okay, so let me summarize what I said. The summary of this slide is saying that inside a non-static method, you can instantiate regularly, like exactly other classes, right? But if we have a static method, then we need some extra efforts. What does it mean? So, for example, here I want to instantiate this inner class, right? I want to instantiate this inner class. Then uh, I would need to instantiate the outer class first. Okay, so let me show you how we can do that. So my author class, and let me call it just my author. All right. So first we need to instantiate the author class, and then we need to use this reference here, and then dot new like this. So in this way, we can instantiate an inner class inside an static method. All right. So this syntax probably is new for some of you guys. Okay. And then we can use that, right? So just my inner, let me see what I get here. I have the name because it's still public, and also let me see. Yeah, we don't have anything else. Let me see. The Oh, this is private. If I make this method as the public, yeah. So you see the same rules uh, applicable here. So you see an inner method. You can call that from now on. Okay, let's see what we got here. Yeah. So this syntax is a new syntax for some of you guys. All right. Okay, so now the question is how it looks like after compiling. That's another good question. Let me show you a quick demo. Uh, so I have inside this folder my author, right? For simplicity, I put it somewhere that I can compile it very quickly. All right. So if you look at this inside of this, my author is just I put an inner here and I added the main method to be able to run the my author. Okay, it just prints something. All right. Okay, so let me compile this. You know that you can click on here and then type the CMD. It will create a Windows shell for you, and then very easily Java compiler and star point Java. Yeah. Okay, so now look at the content of this folder, you see two classes, I mean class files were added here. So one of them is the name of my author, which is the class I just had this guy, my author. But we have another one here, my author dollar sign my inner. So it means that all of the inner classes will be compiled with a different file, a class file like this. All right. Okay. So, but the point is, of course, you cannot run it because that inner class is an uh, has dependency to outer class. So, for example, if let's say Java, this guy, my author, see, could not find or load. Actually, we need to remove this class, point class. You see, main method not found, and there are a lot of things, yeah, public static void, yeah, all right, but of course we can uh, just run the my author, of course, yeah, that main method just run, you see, I was just run. Anyway, so let's get back to our slide. uh, yeah, exactly the same thing that I just explained, and here all of these are for your reference. Okay, now the question is, how can we instantiate an inner class from outside? Outside of what? Outside of the even author class, my author class, in another class. Is it possible? Yeah, it is possible, but you never ever do it. This is really, really the worst design ever. If you need to instantiate an inner class of another class inside your class, just rethink about your design. This is the worst design ever, I believe. All right? Okay, so if you really need that to instantiate that inner class, you need to create a file for that. You make it a public class or public or whatever, right? So it needs to be an independent class in that case. What is static nested class? Okay, so a static nested class, it looks like the inner class, but we have a static keyword here. Of course, before that, we can have public, protected, whatever, right? So let me see here. So my inner class, so this is a method. Uh, we can get rid of all of this to simplify everything. So this class, we can have a static class here. Okay, so now we need to discuss about the restriction and all of this stuff. All right, so let me remove this, make it a little bit clean to be able to talk about that. Okay, let's see. So we called it a static nested class mostly, but it is also known as a static inner class or a static class. Okay, so as its name is saying, it's a static member, right? So since it is a static member, it has its own restrictions. So you remember that if we have a static method inside the author class, let's say here, so this is a static member, right? So what is the, what it can access? The static other static members, right? So for example, you cannot have access to the X. If you say this, then it will complain. What is the complaint? It is complaining that, oh, you cannot make a static reference to a non-static field. So this is not a static. But if you make it static, then there is no problem. So static members, static methods, so far, based on our knowledge, can have access to the static other members, right? And the same thing happening here, right? Uh, okay, so let me explain what is the ingredients of this static class first, then we will get back to this. So it can have any kind of uh, members, including static members. You remember the inner class couldn't have a static member. So since this is a static class right now, and if I make this static, there shouldn't be any complaint, you see? And how about this method? The same thing. No problem at all. All right. So bottom line, a static nested class can have any kind of members, including the static. All right. Okay. And also from the access modifiers point of view, all of the members can have all of these four things that we are familiar with, right? Let's quickly see one of them, for example. So this guy, it can be private. Yeah. The method, for example, can be default. No problem. Protected. Yeah, no problem. You see, all of this access modifier is fine for this. Uh, and as I explained before and put it here for your reference, it can have access only to the static members of the author class. All right. Another question is how can we instantiate it? Very easy. Um, just like a regular um, class. Uh, so you see here, I instantiated this here as an instance variable, no problem. Let me copy and paste it inside uh, here. Um, okay, and you see there is no problem. Even inside the static, let me see. Uh, yeah, I'm sure that you have a question. If it is not a static, what would happen? Yeah, no problem. Anyway, so you can instantiate it very simply and regularly like other classes. Okay. Now I want to ask a very, uh, let's say, bad question. Is it possible again, you instantiate a static nested class in other classes? Yeah. So we have this my author class here, and this is a static uh, nested class here, and we want to instantiate it in other class. Okay, so let me see here. So I'm gonna add another class here. Let's call it other class. My uh, other class. Okay, now the question is, how can I instantiate that static class here? I am not advocating this. It's a worst thing ever. But since you need to read other developers' code, they might be, crazy and use this. So yeah, just let's see. Let me create a main method here, and let's see how we can instantiate that here. All right. Okay, so to instantiate that uh, class, you would need to reference it as a static member. How? Yeah, so just reference the its author class like this. My author, and yeah, you see my inner. Okay, so let me look at this. My inner, yeah, it's public. That's why we can see that, right? Actually, because it's in the same package, if I remove this and make it as a package, there shouldn't be any problem as well. Okay, so here, let me see, we can see that here. Yeah, again, my inner is here. So my inner, and then let's call it something. Let's call it, for example, object equal to. Again, you would need to reference the my author here again, and again it gives you the my inner and semicolon like this. Now you can use this uh, object. Let's call it my um, inner, something like that, and then you can use this reference and see what you get here. Equal get hash notify. Yeah, it cannot see anything. Let's go here, and that's because uh, let me make it public and make this guy public as well. And this is protected. I think it's fine for that. Okay, so yeah, you see an inner, the method, it can be seen here, and the name can be seen here as well. All right. So this is the way that we instantiate a static nested class in other classes, and never ever do this, right? You will be arrested if you do this, right? Okay, so I just put it here because you need to be familiar with it, because you need to read the other's code. Even though I believe, nobody is so crazy to do this, but yeah, this is some, option that Java gives us. Okay, so let me finish with some notes here. Uh, in general, try not to use the inner classes because it increases the complexity of the code. But if you need really, sometimes you really need, right? Uh, so always start with the static nested class. It's very closer to the regular class, right? So always start with this one. And if you really need a non-static thing, then go ahead with the inner class. All right. I'm gonna stop here. See you guys in the next lecture.